November 14th, 1942, 2305 hours. Iron Bottom Sound, Guadalcanal. The darkness was absolute. No moon broke through the overcast sky. Starlight never reached the water through the cloud layer. The surface of the Sound lay black and featureless, waves barely visible even to sailors who'd spent years at sea. It was perfect darkness for a man blind to electronics, and catastrophic darkness for a man with radar. Admiral Willis Augustus Lee stood on USS Washington's bridge, headset connecting him to the fire control parties below decks. He was receiving constant updates from the radar plot. Contacts appearing on the scope. Range decreasing. Multiple targets moving southward in organized formation. Lee was 54 years old, born in Kentucky, a Naval Academy graduate from 1908. But his expertise had nothing to do with the traditional skills that defined naval officers. Lee was a marksman. In 1920, he'd competed in the Antwerp Olympics representing the United States. He'd won 7 medals, 5 gold, 1 silver, 1 bronze, in shooting competitions. His performance remained an Olympic record for 6 decades until someone equaled it in 1980. That background in precision marksmanship shaped how Lee thought about naval combat. Rifle shooting at distance taught fundamental lessons. Wind drift accumulated over range. Temperature variations affected powder burn rates. Barometric pressure altered bullet trajectories. Distance measurement had to be precise. Calculation had to account for multiple variables. Small errors compounded into misses. Lee had spent his career applying these principles to naval gunnery. He understood that hitting targets required measuring all the factors that affected projectile flight and calculating correctly. For decades, navies had relied on optical rangefinders and visual spotting. Lee recognized that radar could provide superior data. Between the wars, Lee had served as director of fleet training at naval operations. He'd worked on fire control systems development. When radar emerged in the late 1930s, Lee immediately grasped its potential. He'd studied British combat reports from the Atlantic. He'd attended technical briefings on radar capabilities. He'd visited research facilities developing the equipment. By the time radar-equipped ships joined the fleet in 1941 and 1942, Lee probably understood the technology better than any flag officer in the Navy. Most senior officers viewed radar as an experimental tool, interesting, possibly useful, but unproven. Lee viewed it as revolutionary. USS Washington had received her SG surface search radar during a refit in August 1942. The SG was cutting-edge technology. It used microwave frequencies around 3,000 MHz, providing resolution far superior to earlier radar systems. The antenna rotated continuously, scanning 360 degrees, displaying contacts on a plan position indicator screen that looked like a circular map. Operators could see bearing and range to multiple targets simultaneously. The system worked in complete darkness, fog, rain, or smoke. It could detect battleship-sized targets at 30 miles range. Washington also carried Mark III fire control radar mounted on her main battery directors. This system provided precise range data, accurate to within 40 yards, plus 0.1% of range. At 10,000 yards, the error would be less than 50 yards. Optical rangefinders in the best daylight conditions might achieve similar accuracy. At night, optical rangefinders were essentially useless. Washington's Mark III radar worked perfectly in darkness. The fire control system integrated this radar data into the Mark VIII range-keeping computer, essentially a room-sized mechanical calculator located in the plotting room below the armored deck. The machine weighed several tons and required 3 operators. It accepted inputs: own ship course and speed, target bearing, target range, target course, and speed. Estimated from radar tracking, wind direction and speed, air temperature, and dozens of other variables affecting shell trajectory. The computer continuously calculated where the guns should point, so shells fired now would intersect with the target's future position. The calculation had to account for shell flight time, typically 20 to 30 seconds. During that time, both Washington and the target would move. Lee had trained Washington's crews in radar-directed gunnery throughout late 1942. His approach was radical for the era. Traditional doctrine said radar was a backup to visual systems. Use radar to find targets, then switch to optical control for firing. Lee inverted this hierarchy. He made radar the primary sensor. He reorganized fire control procedures so radar operators worked directly with gun directors and plotting rooms. Information flowed from radar to fire control without going through bridge officers who might question the data. Lee drilled his crews constantly, track targets on radar, calculate firing solutions from radar data, fire without visual confirmation, trust the electronics. The crew understood what they were being asked to do. Fire at a target they couldn't see, using data from equipment most sailors didn't fully understand, trusting calculations from a mechanical computer the size of a small room. It violated every instinct developed through naval training. Visual confirmation had been the foundation of naval combat for centuries. Now they were being asked to abandon that principle entirely. In January 1942, Washington had fired her main battery at night during training exercises in Casco Bay, Maine. Both times the gunnery was directed entirely by radar. No visual sighting of targets, no optical range finding, just radar providing data to the fire control computer. Both times, Washington's shells landed close enough to target sleds to convince Lee that radar could control accurate fire at ranges where visual spotting was impossible. But training exercises were one thing. Combat with ships maneuvering and shooting back was entirely different. The test came on November 14, 1942. Intelligence reports indicated a major Japanese bombardment force was approaching Guadalcanal. Vice Admiral Nobutake Kondo was bringing battleship Kirishima, heavy cruisers Atago and Takao, light cruisers Sendai and Nagara, and 9 destroyers. Their mission was to shell Henderson Field and land reinforcements. If the airfield was destroyed, Japanese forces could retake the island. The strategic situation was desperate. Guadalcanal represented the first American offensive of the Pacific War. If it failed, the entire strategy of island hopping toward Japan would be questioned. Admiral William Halsey had almost nothing to stop the Japanese bombardment force. Most other warships in the area were damaged or low on fuel or ammunition. The cruiser force was shattered. He had one operational aircraft carrier, USS Enterprise, but carrier aircraft couldn't fight at night. His option was to strip Enterprise of her battleship escorts and send them into Iron Bottom Sound for another night engagement. It was calculated risk. If the battleships were sunk, Enterprise would be vulnerable, but if Henderson Field was destroyed, Guadalcanal would be lost anyway. Task Force 64 consisted of USS Washington, USS South Dakota, and 4 destroyers: USS Walker, USS Benham, USS Preston, and USS Gwynn. It was everything available. Lee's plan was direct. Position the destroyers to intercept and engage the Japanese destroyer screen. Use the destroyers as an expendable shield to deal with Japanese destroyer attacks and absorb initial torpedo salvos. Keep the battleships back in darkness where Japanese visual spotting couldn't locate them. Use radar to track Japanese capital ships. Wait for optimal range, then open fire with calculated salvos. The plan required perfect radar performance, perfect fire control calculations, and sufficient luck to avoid being hit by torpedoes or Japanese searchlights. Lee accepted these risks because any other approach meant fighting on Japanese terms. Fighting on Japanese terms meant losing. The Japanese had spent 2 decades perfecting night combat tactics. They had superior optical equipment, intensive training in low-light conditions, and aggressive doctrine built around rapid torpedo attacks and close-range gunnery. At the Battle of Savo Island in August, Japanese cruisers had surprised an Allied force and sunk 4 heavy cruisers in 32 minutes. The Japanese understood a fundamental truth. Darkness neutralized American advantages in firepower and industrial strength. At 2300 hours, Lee's formation rounded the western tip of Guadalcanal and headed north into Iron Bottom Sound. The passage between Guadalcanal and Savo Island was confined space, barely 8 miles wide. Maneuvering room for battleships was limited. The water was filled with wrecks from previous battles. Survivors from earlier engagements floated on rafts. It was about as bad as tactical waters could be for capital ship operations. But Lee had no choice. Washington's SG radar began picking up contacts at 23:05 hours, range 18,000 yards, bearing 330 degrees. Multiple groups of ships moving south. Lee watched the radar plot display. He counted contacts. More than a dozen vessels in 3 organized groups. The Japanese bombardment force was approaching on schedule, exactly where intelligence predicted, moving at the speed predicted, with the ship composition intelligence had reported. Everything matched the intelligence estimate. Lee ordered all ships to battle stations. The destroyers were arrayed in column ahead of the battleships. Walker leading, followed by Benham, Preston, and Gwynn. Washington followed approximately 2,000 yards behind Gwynn. South Dakota was supposed to maintain position 2,000 yards behind Washington, but Captain Thomas Gatch was an aggressive officer who maneuvered independently, seeking to close with the enemy. Lee sent a message over the TBS radio to all ships. "This is Lee. We're going into a big fight. Keep your heads. Stay alert. Trust your instruments." The Japanese spotted the American destroyers first. Destroyer Ayanami, leading the Japanese destroyer screen, detected contacts on the horizon at approximately 11,000 yards. The Japanese possessed no radar, but their optical systems were exceptional. Years of dedicated training for night combat meant lookouts could see farther than most navies believed possible. Dark-adapted eyes, excellent binoculars, powerful optical rangefinders. The Japanese had invested heavily in visual night fighting capability. Ayanami's commander, Lieutenant Commander Saito Tomokatsu, immediately recognized the contacts as enemy warships. Saito made his tactical decision instantly. He would attack with torpedoes first, overwhelming the American screen with the devastating long lance, then illuminate with searchlights and open fire with deck guns. This was Japanese destroyer doctrine perfected through years of night combat victories. Ayanami launched a spread of 8 Type 93 torpedoes. The long lance was the finest torpedo in the world, 24 feet long, weighing 2 tons, powered by oxygen-enriched kerosene that produced virtually no visible wake. The warhead contained 1,000 pounds of high explosive. The weapon ran at 48 knots with a range of 20 kilometers at that speed. American torpedoes typically ran at 45 knots, with maximum ranges of 6,000 yards. The long lance could strike from 3 times farther away at higher speed. After launching, Saito ordered his searchlight operators to illuminate the lead American destroyer. The beam snapped on, stabbing across the dark water. USS Walker was caught perfectly, silhouetted in brilliant light. Ayanami opened fire at 8,000 yards range. Light cruiser Nagara, following behind the destroyer screen, also opened fire. Within seconds, multiple Japanese ships concentrated on the illuminated target. Commander Thomas Fraser on Walker reacted with combat instinct. He ordered hard left rudder to evade torpedoes, returned fire with Walker's 5-inch guns, and requested permission from Lee to launch his own torpedoes. Lee refused. He had calculated that American and Japanese torpedoes running in the same water would create unacceptable friendly fire risks in the darkness. He ordered the destroyers to engage with guns only and maintain their screening position. Fraser launched all 10 of Walker's torpedoes anyway, not to comply with Lee's order, but because trained destroyer captains understood that clearing the tubes provided tactical advantages. He continued firing his remaining guns. Walker was being hit repeatedly, Her forward superstructure was struck multiple times. Fires started on the bridge. The forward 5-inch mount was destroyed by a direct hit. At 2326 hours, a shell penetrated Walker's forward magazine. The explosion was catastrophic. The entire forward section of the destroyer from the bow to the bridge disintegrated in a massive fireball. The vessel broke in two. The forward section sank immediately. The aft section remained afloat for perhaps 30 seconds before capsizing and sinking. Commander Fraser died instantly. Most of the crew died in the explosion. 76 men were killed. Approximately 60 survivors went into the water wearing life jackets. Preston was second in line, about 600 yards behind Walker. Lieutenant Commander Max Storms saw Walker explode ahead. He continued forward toward the enemy. Preston's radar showed multiple Japanese ships. Storms ordered his guns to engage the nearest contacts. Preston's 5-inch battery opened fire at destroyer Ayanami and light cruiser Nagara. Japanese destroyers Uranami and Shikanami returned fire. Preston was hit almost immediately. Multiple shells struck within seconds. One destroyed the SG radar antenna. Another penetrated the after-engine room, causing superheated steam to rupture from ruptured lines. The compartment became a furnace, killing everyone inside instantly. Preston lost power to her after guns and half her propulsion. More shells hit. Her bridge was struck, killing the executive officer. Communications were cut between the bridge and the rest of the ship. Fires spread amid ships where fuel oil tanks had been ruptured. At 2330 hours, a Type 93 torpedo slammed into Preston's starboard side amidships. The massive explosion broke the destroyer's keel literally. The ship's back was broken. She began settling rapidly. Max Storms ordered abandoned ship and stayed on the bridge helping men escape. Less than 30 seconds after the abandoned ship order, Preston rolled over to starboard and sank. 116 men died, including Storms. About 90 men survived and went into the water. Benham was third in line. Lieutenant Commander John Taylor saw both lead, destroyers sinking ahead. Explosions lit up the darkness. Burning fuel oil spread on the water. Taylor ordered emergency turn to starboard to avoid collision with wreckage and survivors. As Benham turned, a Type 93 torpedo struck her bow. The torpedo hit at the waterline about 30 feet back from the stem. The explosion was enormous. The entire forward section from the bow back to the bridge was blown off. The forward gun mounts simply disappeared. The bow structure vanished. Anchor chains, cable lockers, forward crew berthing spaces, forward magazines, all gone. About 60 feet of the ship ceased to exist, but the torpedo hit forward of the main watertight bulkhead. The bulkhead held. Water rushed in through the destroyed bow section, but stopped at the bulkhead. Benham's stern section from the bridge aft remained intact and watertight. Taylor managed to stabilize the ship. The engines still worked. Steering was functional using the rudder, but Benham could only make 5 knots with her bow missing. The water resistance was too great. She was out of the fight. Remarkably, Benham stayed afloat all day November 15th. She was eventually scuttled by gunfire from USS Gwynn. All crew members survived. Nobody was killed by the torpedo hit. Gwynn was fourth and last in line. Lieutenant Commander John Fellows saw 3 lead destroyers hit ahead. Explosions and fires indicated the destroyer screen was being overwhelmed. Fellows ordered Gwynn to engage with all guns and prepare to maneuver independently. Gwynn's 5-inch battery fired at multiple Japanese targets. At 2032 hours, a Japanese shell hit Gwynn's after-engine room, killing several men in the engineering spaces and disabling one engine. Gwynn remained operational on her remaining engine, capable of making about 20 knots. In 15 minutes, the American destroyer screen had been effectively destroyed. 2 destroyers sunk with heavy loss of life, one crippled and withdrawing with her bow blown off, one damaged but still operational. The Japanese destroyer and cruiser screen had executed their night combat doctrine perfectly. They had engaged aggressively with torpedoes and gunfire. They had overwhelmed the American destroyers with concentrated fire. They had broken through the screening force and cleared the way for Kirishima and the heavy cruisers to engage the American battleships. This was exactly the scenario Lee had anticipated, but accepted as unavoidable. His destroyers couldn't match Japanese destroyers in night combat. The Japanese had better torpedoes, better training, better tactics, and more experience. But Lee had positioned his destroyers to absorb the initial attack and protect the battleships. The destroyers had done their job at terrible cost. Now everything depended on the battleships using their radar advantage before the Japanese found them. USS South Dakota had maneuvered independently when the destroyer action started. Captain Thomas Gatch was an aggressive officer who wanted to close with the enemy. He moved South Dakota ahead of Washington to engage. At 2338 hours, South Dakota's SC air search radar picked up surface contacts at 18,000 yards. SC radar was less capable than SG, but could detect large ships at long range. Gatch ordered his main battery to prepare to engage. Then, disaster struck. South Dakota's electrical system failed completely. The failure was caused by human error compounded by poor design. During the afternoon, electrical repairs were being conducted. A circuit breaker tripped. The chief engineer manually reset the breaker while it was still under load, a violation of Navy regulations because it could cause cascading failures. That's exactly what happened. Resetting the breaker under load caused it to trip again. When it tripped, it caused other breakers in the circuit to trip. The failures cascaded through the electrical distribution system. Within seconds, the entire ship lost power. Everything went dark. Radar screens went black. Gun directors lost power. Fire control computers shut down. Communications went dead. Ventilation stopped. Even emergency lighting failed in some compartments. Damage control teams worked frantically in complete darkness, trying to restore power. They had flashlights and battle lanterns, but resetting breakers and troubleshooting electrical systems in darkness was nearly impossible. The engineering crew managed to restore partial power within about 5 minutes, but the damage was done. South Dakota's combat capability was shattered at the worst possible moment. Without radar, South Dakota was blind. Without fire control power, her main battery couldn't be aimed. Without communications, Gatch couldn't coordinate with Lee or with his own gun crews. South Dakota continued moving forward on momentum and manual steering, heading directly toward the Japanese force without sensors or working weapons. At 01:01 hours, power was partially restored. Some radar systems came back online. Fire control systems rebooted, but the ship had drifted during the power failure. South Dakota had sailed to within 5,000 yards of the Japanese force, far closer than Gatch intended. Japanese cruiser Atago detected the American battleship at close range and illuminated her with a searchlight. The powerful beam found South Dakota immediately. She was perfectly silhouetted by the burning American destroyers behind her, backlit by the fires. Every Japanese ship in range opened fire. Kirishima fired her main battery of 14-inch guns at a range of 5,500 yards. This was point-blank range for battleship guns. The Japanese shells crossed the distance in about 8 seconds. Heavy cruisers Atago and Takao fired their 8-inch guns. Light cruiser Sendai fired 6-inch guns. Multiple destroyers fired 5-inch guns. South Dakota was hit by shells of every caliber. The ship was struck at least 27 times in 3 minutes. Most hits came from 8-inch, 6-inch, and 5-inch guns. These shells couldn't penetrate South Dakota's armored belt or turret faces, but they destroyed everything topside. The forward main battery director took a direct hit from a 14-inch shell. The shell didn't penetrate the armored director, but the impact destroyed the optics and killed the crew inside through concussion alone. The radar antennas were shattered by shell fragments. Gun mounts were hit. The number 3 turret took an 8-inch hit on the barbette, but the shell didn't penetrate. Fires started in multiple locations. The superstructure was riddled with holes. 39 men were killed. 59 were wounded. The ship looked like she'd been through a scrap metal shredder. South Dakota's armor did its job. None of the hits penetrated vital spaces. The engines kept running. The ship maintained speed. The main battery turrets could still fire in local control without the directors. But South Dakota was effectively out of the fight. She couldn't use radar. She couldn't use centralized fire control. She was partially blind and heavily damaged. Captain Gatch ordered an emergency turn to starboard to escape the Japanese formation. South Dakota turned hard and disappeared back into darkness, heading south away from the enemy. Her sacrifice had achieved one critical result. She had drawn every Japanese ship's attention. Every gun in the Japanese formation had been focused on South Dakota. While South Dakota was being pounded, USS Washington was invisible in the darkness, tracking every enemy ship on radar, preparing to fire. The Japanese thought they'd won. In less than 20 minutes, they'd destroyed or driven off every American ship they'd engaged. 4 destroyers sunk or crippled, 1 battleship damaged and retreating. Admiral Kondo on cruiser Otago congratulated his force on their success. He ordered the formation to reform and proceed north to bombard Henderson Field. The primary mission could now proceed unopposed. The Japanese commanders didn't know that USS Washington existed. In Washington's plotting rooms and fire control directors, the radar operators and gunnery teams possessed complete tactical information. The SG radar showed all Japanese ship positions with perfect clarity. The returns were distinct and easy to track. The Mark III fire control radar mounted on the forward main battery director was locked onto the largest contact, tracking it continuously as both ships moved. The radar measured range every few seconds. The Mark VIII range-keeping computer continuously updated the firing solution. Target bearing, target range, target course, and speed estimated from radar plot tracking, own ship course and speed, wind direction and speed, all the variables fed into the mechanical calculator. The solution was ready. All turrets were loaded with armor-piercing shells. The guns were trained on target and elevated to the calculated angle. Everything was ready. Washington needed only permission to fire. Admiral Lee stood on the bridge with Captain Glenn Benson Davis. Lee wore a headset connected to the radar plot and fire control circuits. He could hear everything the operators were saying. He watched the radar plot display showing the tactical situation. He could see the Japanese battleship clearly on the screen. Range 8,400 yards, bearing moving slowly northwest toward Henderson Field. The target was moving at approximately 20 knots with no evasive maneuvers. The Japanese ship had no idea Washington existed. They'd seen only American destroyers in South Dakota. They didn't know a fully functional American battleship was tracking them on radar, calculating firing solutions, waiting for the optimal moment. Lee had the perfect setup. His ship was invisible. His target was fully illuminated on radar. His guns were ready. This was the moment everything had been building toward. The moment that would prove radar could dominate naval combat. Lee looked at Captain Davis and said simply, "Stand by, Glenn. Here they come." Davis gave the order that would change naval warfare forever. Main battery commenced firing. At exactly 0100 hours, 1 a.m. on November 15, 1942, USS Washington opened fire. All 9 16-inch guns in 3 triple turrets fired together in a single massive salvo. The sound was indescribable. The blast pressure was so intense it could rupture eardrums from a quarter-mile away. The muzzle flash lit up the entire sky like lightning. The ship shuddered and heeled slightly to starboard from the recoil force. Nearly 4,000 tons of metal recoiling simultaneously. 9 shells, each weighing 2,700 pounds, flew toward Hiroshima at 2,600 feet per second, approximately 1,800 miles per hour. The shells were armor-piercing projectiles, forged steel bodies with hardened noses designed to penetrate armor plate. Inside each shell was about 40 pounds of high explosive with a base detonating fuse designed to explode after penetration, not on impact. The shells would punch through armor, travel into the ship's interior, then explode inside where they would cause maximum damage. The ballistic trajectory was carefully calculated. The shells left Washington's guns at 45-degree elevation. They arced upward to a peak height of about 20,000 feet, then descended at a steep angle toward the target. The steep angle meant the shells would penetrate Kirishima's deck armor, which was significantly thinner than her side armor. The shells would take approximately 20 seconds to reach the target. The Japanese on Kirishima had no warning whatsoever. They couldn't see Washington. Their lookouts were focused forward toward Henderson Field. The first indication they had of danger was when 9 shells arrived. The first salvo hit Kirishima's superstructure and foredeck. 2 massive shells struck the forward superstructure directly. Both exploded in cascades of fire and destruction. The bridge area was smashed. The rangefinder on top of the bridge tower was destroyed. Fire control equipment was completely wrecked. Communications lines were cut. Electrical cables were severed. Fires started immediately as fuel lines and hydraulic lines ruptured. Captain Sanji Iwabuchi was on the bridge when the shells hit. He was knocked down by concussion but survived. Most of the bridge crew was killed or wounded. Iwabuchi got to his feet and tried to assess the damage. Smoke filled the bridge. Electrical power flickered. Communications to other parts of the ship were cut. He couldn't determine where the firing was coming from. He could only see muzzle flashes from somewhere to the south, but the range was impossible to estimate. In Washington's turrets, gun crews were already reloading. The hydraulic rammers pushed new shells into the breaches. Each shell was mechanically lifted from the magazine below, brought up through the turret structure, and loaded. Powder bags followed. Each gun required 6 powder bags. The breeches closed and locked automatically. The entire loading cycle took about 30 seconds. The second salvo was ready to fire. The fire control solution had been updated based on the latest radar ranging. Washington fired again at 01:03 hours. This salvo hit Kirishima forward and amidships. 1 shell penetrated the armored deck near turret number 1, the forwardmost main battery turret. The shell went through the deck and exploded in a compartment just above the forward magazines. The explosion caused severe fires and flooding. Damage control parties immediately flooded the magazines to prevent catastrophic detonation. This saved the ship from exploding entirely, but it also disabled turret number 1. With the magazine flooded, the turret couldn't be supplied with ammunition. Another shell hit the forward superstructure and destroyed the backup fire control position. A third shell hit the foremast and brought down the main fire control director tower. The director fell onto the deck, crushing men below. Kirishima's main battery fire control was now effectively destroyed. Kirishima tried desperately to return fire. Her aft turrets 3 and 4, were still operational. The local gun captains in those turrets could see muzzle flashes from Washington's guns. They trained their turrets toward the flashes and fired. Kirishima got off several salvos of 14-inch shells at Washington, but without working fire control systems and without radar, the Japanese gunners had no accurate range. They estimated Washington was about 10,000 yards away based on the brightness of the muzzle flashes. They were close. Washington was actually at 8,600 yards, but close wasn't good enough. The Japanese shells flew toward where Kirishima's gunners thought Washington was. The shells passed over Washington's masts, missing by perhaps 200 feet. One witness on Washington observed, "They must have been mighty close, but close doesn't count." Washington's third salvo fired at 01:04 hours, all 9 guns again. This salvo concentrated amidships. 3 shells hit Kirishima's machinery spaces. 1 shell penetrated the side armor and exploded in the forward engine room. The explosion was devastating. Boilers were ruptured. Steam lines burst. Turbines were damaged. The engineering crew was killed or driven out by superheated steam. Another shell hit near the after-engine room with similar results. Kirishima started losing power. Her speed dropped from 20 knots to 15, then to 10. The ship was dying. The fourth salvo fired at 01:01 30 hours. Two more penetrating hits amidships and aft. One shell went through the deck and exploded in a machinery space near the steering gear. The hydraulic lines that powered the steering were destroyed. Kirishima lost steering control. The ship began turning slowly in a point circle, unable to control her direction. Another shell destroyed the hydraulic pumps that powered the training mechanism for turrets 3 and 4. Kirishima's aft main battery was now useless. The turrets couldn't be trained or elevated. The ship had lost all main battery capability. The fire control teams in Washington's plotting rooms watched the radar return continuously. They could see the target was slowing and appearing to turn. Something was clearly wrong with the Japanese ship. The firing solution was updated for the changing target motion. The fifth salvo fired at 01:02 hours. Two more hits. One shell exploded in crew berthing spaces on the port side. Over 100 men were killed instantly. The other shell hit the after superstructure and destroyed the emergency steering position. Fires were now burning from bow to stern. Kirishima was completely ablaze. The Japanese battleship looked like a floating inferno against the darkness. The sixth salvo fired at 01:02 30 hours. One massive hit near the waterline on the starboard side. The armor-piercing shell penetrated the side armor and exploded in a compartment already damaged by earlier hits. Water poured in through the hole. The flooding was uncontrollable. Kirishima developed a list to starboard that grew steadily worse. The pumps couldn't keep up with the flooding. More compartments were being deliberately flooded to prevent magazine explosions. The weight of water was dragging the ship down. The seventh salvo fired at approximately 01:03 hours. The final shots of the engagement. The entire surface action from opening fire to ceasefire lasted 7 minutes. In those 7 minutes, Washington had fired 9 full salvos of 16-inch ammunition, 75 massive shells, each weighing 2,700 pounds. The ammunition fired in those 7 minutes alone weighed over 100 tons. The propellant charges for those shells weighed another 70 tons. Modern analysis of Kirishima's wreck, conducted decades later using sonar surveys, suggests between 17 and 21 total hits from the 16-inch guns, many below the waterline where they couldn't be observed during the battle. Washington's 5-inch secondary battery also fired throughout the engagement, with approximately 107 rounds expended. 17 to 25-inch rounds hit Kirishima. These smaller shells couldn't penetrate armor, but they destroyed everything topside. Gun mounts were knocked out. Searchlights were shattered. Boats and davits were destroyed. The superstructure was riddled with holes. Men caught in the open were killed by fragments. At 01:07 hours, 7 minutes after opening fire, Lee ordered ceasefire. Kirishima was clearly finished. She was dead in the water, burning from multiple fires, listing heavily to starboard, unable to steer or fight. There was no point wasting ammunition on a sinking ship. Washington had other concerns. Japanese destroyers were launching torpedoes in desperation. Lee had to maneuver to avoid them. Type 93 torpedoes, long lances, were already in the water. Every Japanese destroyer had launched their full load when they detected Washington's muzzle flashes. Dozens of torpedoes were running toward Washington's last known position. The torpedoes ran at 48 knots with almost no visible wake. They were nearly impossible to see at night. Lee ordered emergency maneuvers: hard left rudder, increase speed to 25 knots, then hard right rudder, then left again. Washington zigzagged through Iron Bottom Sound at high speed. Lookouts on Washington spotted torpedo wakes crossing ahead of the ship. More wakes passed astern. Washington was surrounded by torpedoes running in multiple directions, but Lee's constant maneuvering kept the ship clear. The Japanese had aimed at where Washington should have been based on her gun flashes. They couldn't adjust aim without radar. Lee's zigzag pattern meant Washington was never where the torpedoes expected her to be. It was a close call. Several torpedoes passed within 100 yards, but none hit. Washington maneuvered through the torpedo water and emerged without damage. At 0300 hours, Lee ordered Task Force 64 to withdraw south. The mission was accomplished. Kirishima was sinking. The Japanese bombardment had been stopped. Henderson Field was safe. There was no reason to stay and risk further damage. Lee formed up with the damaged South Dakota and surviving destroyers and headed back toward Guadalcanal. Behind Washington, Kirishima was in her death throes. Japanese destroyers Asagumo and Teruzuki came alongside to evacuate survivors. Captain Iwabuchi and most of the crew abandoned ship. Over 2,000 men were rescued. Light cruiser Nagara attempted to take Kirishima in tow, but the damage was too severe. The battleship was flooding in multiple compartments. The list to starboard reached 18 degrees and kept increasing. The ship was settling by the bow. At 0325 hours, 3 hours and 25 minutes after Washington's first salvo, Kirishima capsized and sank. 212 men went down with her. The ship sank approximately 7 to 12 miles northwest of Savo Island, in water over 2,000 feet deep. USS Washington had accomplished what no other American battleship would achieve during World War II. She had defeated an enemy battleship in a one-on-one surface engagement. More importantly, she had proven that radar could dominate naval combat. Washington had tracked Kirishima on radar for over 20 minutes, while remaining invisible to Japanese lookouts. Washington had fired 9 salvos of calculated fire without visual spotting and achieved devastating accuracy. The engagement demonstrated that electronics had become more important than eyesight in naval warfare. Understanding the full significance of the victory took time. The official Navy action reports focused on Admiral Lee's tactical skill and crew training. Captain Davis wrote in his report that radar was critical, but many readers interpreted this as radar being helpful rather than decisive. Senior officers still thought of naval combat in traditional terms: visual range gunfire and torpedo attacks. The idea that ships could fight entirely by electronics was difficult for men trained in traditional methods to fully accept. But Captain Davis understood what had happened. In his action report, he made a statement that would prove prophetic. Radar has forced the captain or officer in tactical command to base a greater part of his actions on what he is told rather than what he can see. This was revolutionary. For centuries, naval commanders had operated by looking at the enemy and making decisions based on visual information. They could see the enemy formation. They could see where shells were landing. They could see damage on enemy ships. Now they would sit inside ships and make decisions based on electronic displays showing dots and numbers. The nature of naval command had fundamentally changed. The Navy began developing formal procedures for organizing radar information after Guadalcanal. Before the battle, radar operators worked in scattered locations around ships with no standardized procedures. After the battle, the Navy centralized radar displays, plotting tables, and communication systems into dedicated spaces. By January 1943, the Navy formally designated these spaces as Combat Information Centers. Trained personnel staffed the CIC to maintain situation awareness for the commanding officer. The CIC concept was developed directly from lessons learned at Guadalcanal. If Washington had possessed a fully developed CIC in November 1942, the battle might have been even more decisive. The Navy created formal training programs for radar operators and CIC personnel. Before Guadalcanal, radar training was minimal and inconsistent. After Guadalcanal, the Navy established schools teaching operators how to interpret radar returns, track multiple targets, maintain plots, and communicate effectively with bridge officers and weapons stations. Officers received training in how to command using radar data as their primary information source. The curriculum emphasized that radar wasn't a backup to visual systems. It was the primary sensor, especially at night. Tactical doctrine changed fundamentally. Before Guadalcanal, formations were designed around visual signaling and optical fire control. Ships operated in columns or lines where each ship could see the next. Flag signals controlled maneuvers. After Guadalcanal, formations were designed around radar coverage. Ships with superior radar systems were positioned where they could track the most contacts. Multiple ships coordinated fire using radar data shared by radio. Task force commanders were required to use ships with the best radar as flagships regardless of which ship was most powerful. This represented a complete inversion of traditional doctrine. The impact became apparent within a year. In November 1942, American forces were barely holding their own in night battles against the Japanese. By November 1943, Japanese ships avoided night engagements unless they had overwhelming numerical superiority. 3 night surface actions in the second half of 1943 demonstrated American dominance. At Vela Gulf in August, American destroyers using radar detected Japanese destroyers at long range, maneuvered into position, and destroyed 3 Japanese destroyers with radar-directed torpedo attacks before the Japanese knew American ships were present. At Empress Augusta Bay in November, American cruisers and destroyers defeated a Japanese force using radar-directed gunfire. At Cape St. George in November, American destroyers intercepted and destroyed 3 Japanese destroyers in a night action entirely controlled by radar. American forces took minimal damage in all 3 engagements. Night combat had become an American advantage. The Japanese tried desperately to adapt. They examined wreckage from sunken American ships and found radar equipment. They understood the principle of using radio waves to detect ships, but they were years behind in development. Japanese radar in 1943 was roughly equivalent to American radar in 1941. The equipment was less reliable, had shorter range, and lacked the sophisticated displays that American systems featured. By the time Japan developed working surface search radar comparable to the American SG, it was 1945, and the war was nearly over. Even then, Japanese radar was fitted to only a handful of ships. Japanese commanders also struggled with the psychological impact of fighting an enemy they couldn't see. For 2 years, Japanese destroyer and cruiser captains had dominated night battles through superior training and aggressive tactics. They developed confidence bordering on arrogance. Japanese night fighting doctrine was taught throughout the Navy as the gold standard. Now they were being beaten consistently by ships they couldn't see, firing from ranges where visual spotting was impossible. The confidence built over 20 years of training evaporated. Several experienced Japanese commanders were killed in late 1942 and throughout 1943 trying tactics that had worked perfectly before Guadalcanal. They closed to short range for torpedo attacks and were destroyed by radar-directed gunfire before they could launch. They tried to use searchlights to illuminate targets and were hit by ships firing from beyond searchlight range. They attempted to evade by maneuvering at high speed and were tracked continuously by radar. The fundamental problem was that they were fighting an enemy using a technology they couldn't detect and couldn't counter. It's impossible to develop effective tactics against a capability you don't understand. Admiral Lee understood this completely. After the battle, he wrote a letter to Admiral Halsey that demonstrated remarkable insight and humility. Lee stated that American superiority at Guadalcanal was due almost entirely to radar. He wrote explicitly, "We realized then, and it should not be forgotten now, that our entire superiority was due almost entirely to our possession of radar. Certainly we have no edge on the Japanese in experience, skill, training, or performance of personnel." Lee was absolutely correct. Japanese crews were superbly trained. Japanese officers had more combat experience. Japanese doctrine was more developed. Japanese equipment, especially torpedoes, was in many ways superior. The only American advantage was radar, and that one advantage was decisive. Lee never received full public credit for this insight during his lifetime. He was awarded the Navy Cross for his actions at Guadalcanal. The citation praised his leadership and tactical skill. He was promoted to Vice Admiral in 1944 and given command of all fast battleships in the Pacific Fleet. As commander of Battleship's Pacific Fleet, he participated in every major campaign from 1943 through 1945. But most histories of Guadalcanal focused on the desperate surface actions of November 12th and 13th, where Admirals Callahan and Scott died leading close-range attacks against overwhelming odds. Those actions had clear heroes and dramatic sacrifice. Lee's victory appeared too easy. Washington suffered 0 casualties. She wasn't even scratched. It didn't look like the same kind of heroic struggle. But Lee's victory was actually harder than it appeared. The decision to trust radar completely was radical in November 1942. Most admirals considered radar interesting, but unproven. They'd been trained in an era when visual spotting and optical instruments were the only reliable methods. Radar challenged everything they'd learned. Lee bet his entire force on technology that others viewed skeptically. If the radar had failed, if the data had been wrong, if the fire control solutions had been off by even a few degrees, Washington would have sailed blind into a superior Japanese force and been destroyed. The consequences of failure would have been catastrophic. Henderson Field would have been destroyed. Guadalcanal would have been lost. The entire Pacific offensive would have stalled. Lee's genius was understanding that radar was more reliable than human vision in darkness, and then having the courage to act on that understanding. That understanding came from years of study. Lee had spent 3 years as director of fleet training, studying gunnery systems. He'd worked with engineers developing radar equipment. He'd read British reports on radar use in the Atlantic. He'd attended technical briefings. He'd trained his crews extensively. He knew the capabilities and limitations of radar better than any flag officer in the Navy. When the moment came in pitch darkness with destroyers sinking and another battleship crippled and a superior Japanese force approaching, Lee trusted his radar operators and fire control teams to do something unprecedented. He ordered Washington to fire at a target nobody could see using data from electronics that most officers didn't fully trust. The crews didn't let him down. USS Washington remained in service for the duration of the war. She participated in nearly every major Pacific campaign from 1943 onward. She screened fast carriers at the Battle of the Philippine Sea in June 1944. She was present at the Battle of Leyte Gulf in October 1944. She bombarded Japanese positions during the assaults on Iwo Jima in February 1945 and Okinawa in April and May 1945. She was present at the Japanese surrender ceremony in Tokyo Bay on September 2, 1945. After the war, Washington was used to transport soldiers home as part of Operation Magic Carpet. She made 2 trips across the Atlantic in November and December 1945, carrying over 1,600 soldiers from Europe to the United States. She was decommissioned on June 27, 1947 at the New York Navy Yard and placed in the Atlantic Reserve Fleet. She remained in reserve for 13 years, while the Navy decided what to do with World War II-era battleships. By 1960, it was clear that battleships had no place in modern naval warfare. Aircraft carriers and guided missiles had made gun-armed surface ships obsolete except for shore bombardment. Washington was stricken from the Naval Vessel Register on June 1, 1960. She was sold for scrap on May 24, 1961, to Lipset Division of Lura Brothers Company in New York. The ship was towed to the scrapyard and systematically dismantled. Her 16-inch guns were cut apart with torches. Her armor plates were removed and melted down. Her superstructure was dismantled piece by piece. By the end of 1961, USS Washington had ceased to exist except as scrap metal. A few artifacts were preserved before scrapping. The ship's bell was saved. The ship's wheel was preserved. Some commemorative plaques and deck fittings survived. These items are held in various naval museums and archives. Captain Glenn Benson Davis remained in the Navy after the war. He was promoted to Rear Admiral and commanded Battleship Division 8 during the Marianas Campaign in 1944. He continued advancing and became Vice Admiral. He served as Commandant of the Washington Navy Yard from 1950 to 1952 and as Commandant of the 6th Naval District in Charleston, South Carolina. He retired from the Navy in 1954 after 43 years of service. Davis died on September 9, 1984 in Bethesda, Maryland, at age 92. His contributions to radar doctrine and his partnership with Admiral Lee were recognized by naval historians, but he remained modest about his role. In interviews late in his life, Davis consistently credited Lee's vision and the crew's training for Washington's success. Admiral Willis Augustus Lee never saw the end of the war. On August 25, 1945, 10 days after Japan surrendered, Lee suffered a massive heart attack. He was being ferried in a motor launch across Casco Bay from his shore headquarters to his flagship USS Wyoming, anchored in Portland Harbor, Maine. Lee collapsed in the boat and died before reaching Wyoming. He was 57 years old. The cause was acute coronary thrombosis, essentially a massive heart attack. 3 years of constant stress commanding battleship forces in combat had taken their toll. Lee had been in combat operations almost continuously from August 1942 through August 1945. He'd commanded during some of the most intense naval battles of the war. The physical and mental strain had been enormous. Lee was buried with full military honors at Arlington National Cemetery in Virginia. His grave is marked with a simple white marble headstone. The inscription lists his name, rank of Vice Admiral, and dates of birth and death. It mentions his 7 Olympic medals. It doesn't mention Guadalcanal. It doesn't mention that he proved radar could revolutionize warfare. It doesn't mention that his understanding of technology gave the United States a decisive advantage in the Pacific War. Lee would probably have preferred it that way. He was never interested in glory or recognition. He was interested in solving problems and winning battles. The engagement between USS Washington and Kirishima lasted 7 minutes from first salvo to ceasefire. In that time, Washington fired 75 rounds of 16-inch ammunition and 107 rounds of 5-inch ammunition. The 16-inch shells alone weighed over 100 tons. The propellant charges weighed another 70 tons. The total ammunition expenditure was approximately $150,000 in 1942 prices, equivalent to about $2.5 million in modern currency. The ammunition cost was insignificant compared to the strategic value of the victory. Washington's victory saved Henderson Field from bombardment. Japanese forces never again seriously attempted to destroy the airfield with naval gunfire. Without Henderson Field, American forces on Guadalcanal couldn't maintain air superiority. Without air superiority, supplying and reinforcing the Marines would have been nearly impossible. Japanese aircraft and ships would have dominated the waters around Guadalcanal. The campaign might have been lost. If Guadalcanal had been lost, the entire American offensive strategy in the Pacific would have been called into question. The greater long-term impact was proving that radar could dominate surface naval combat. Before November 15, 1942, radar was viewed as experimental technology that might be useful in some circumstances. After that night, radar became recognized as the foundation of modern naval warfare. Every navy in the world began intensive radar development programs. Ships were retrofitted with radar. New ships were designed from the keel up with radar as a primary sensor. Tactics and doctrine were rewritten around radar capabilities. The era of visual range combat ended. The era of electronic warfare began. The transformation happened remarkably quickly. In January 1942, fewer than 100 American warships had any kind of radar. By January 1945, virtually every American warship had multiple radar systems: fire control radar, air search radar, surface search radar, identification systems. Ships carried half a dozen different radar systems, each optimized for different functions. The electronic equipment became as important as the guns themselves. The lesson from USS Washington's victory isn't ultimately about technology. It's about leadership willing to trust new technology when conventional wisdom says otherwise. Admiral Lee had 34 years of experience in an era when battleships fought with visual spotting and optical rangefinders. Every instinct developed through that lengthy service should have told him to be cautious with experimental electronics. His career had been built on mastering traditional gunnery. He was probably the best gun expert in the Navy. He could have relied on traditional methods because that's what he knew best. Instead, Lee abandoned those methods completely. He committed entirely to radar because he'd done the intellectual work to understand it. He'd studied the engineering principles. He'd examined combat reports. He'd trained his crews extensively. He tested the systems in exercises. He knew radar would work because he'd verified it through study and practice. When the moment came in pitch darkness with destroyers sinking and another battleship crippled and a superior Japanese force approaching, Lee trusted his radar operators and fire control teams to do something unprecedented. He ordered Washington to fire at a target nobody could see using data from electronics that most officers didn't fully trust. The crews didn't let him down. The radar tracked perfectly. The fire control computer calculated accurately. The guns fired precisely. 9 salvos in 7 minutes destroyed a Japanese battleship. 0 American casualties. The victory validated everything Lee had believed about radar. It proved that electronics could be more reliable than human senses. It demonstrated that properly integrated technology could overcome numerical inferiority and tactical disadvantage. That kind of leadership remains rare. Most commanders follow established procedures. They trust proven methods. They avoid risk by doing what has always been done. Innovation requires doing something that hasn't been proven in combat. It requires accepting risk that others won't accept. It requires trusting technology or tactics that haven't been validated by experience. Admiral Lee did all of these things. He organized his ship around unproven technology. He trained his crew to fight in ways no Navy had fought before. He committed his entire force to a battle plan that depended on radar working perfectly, and he succeeded. The result changed naval warfare forever.